Okay, boys and girls, today we're going to go on to Unit 3, Lesson 2, which are equivalent ratios. Yesterday we were working on ratios, and today we are going to be looking at equivalent ratios. Now remember, at any time you can stop the video, pause it, and continue writing or continue solving a problem, and then move on. So our big idea are equivalent ratios and proportions are used in math as a way of thinking and expressing relationships between quantities. And so we have that part written here. Now our objective for today is mathematicians, which is you, can identify the relationship between two quantities using ratios and equivalent ratios. Now yesterday was the green part, today we're adding the equivalent ratios part. So go ahead and pause it and write this down and think about what it means, and then we'll move on. Now we're going to go into our definition of equivalent ratios. Now remember, yesterday we looked at ratios, and a ratio is a way to compare two quantities, and we can write it in three forms. We can write it in word form, we use the word two. We can write it in fraction form, and we put the little fraction bar. Or we could write it in ratio form, and we put our colon. Now, for example, what is the ratio of 5th graders in our class to 6th graders? Now, since I said 5th graders first, that number will always go first. We have 10 5th graders in our class. So the ratio is 10. 10 will go on top, 10 will go over here, and we have 15 6th graders. So the ratio is 10 to 15. This is our ratio in our class. Now we also have an equivalent ratio that we can pull from here, and we'll explain that a little bit more. What is an equivalent ratio? An equivalent ratio are two ratios that represent the same value when simplified. And I gave you an example here. 1/2 is equivalent to 2/4. 2/4 is equivalent to 3/6. 3/6 is equivalent to 4/8, and 4/8 and 5/10 and 6/12. Now all of these are equivalent. This is equivalent to this. Why? Because when we simplify it, when we go and we simplify those fractions or these ratios, they both come back to equal 1/2. So 4/8 would equal 1/2, and 6/12 would equal 1/2. Both of them, when simplified, would equal 1/2. So you can remember, pause it and continue when you're done. Okay, so now we're going to go on to example 1, 2, and simplifying ratios. But for example 1 and 2, I'm going to have to pull up a different screen so that you can see. Now if you notice, for example 1 and 2, I have some colored dots here. And so what we're asking for is the ratio of blue dots to red dots. So we're looking for the ratio of blue dots to red dots. Now when I go and I look at my blue dots and my red dots, and I'm going to pull up our presentation here. When I have my blue dots and my red dots, now we can start counting all the blue dots. 1, 2, 3, 4, 5, 6. We also have some yellow and we have some green in there. Here's what's happening. I'm going to take away the yellow and the green, and now I'm just left with blue and red. So I'm just going to get rid of those. And my ratio of blue dots to red dots will end up being 6 to 3. The ratio of blue to red dots is going to be 6 to 3. But I can simplify that, and it can be simplified to 2 to 1. It could be simplified to 2 to 1, which means for every 2 blue dots, I have 1 red dot. So if I look at my paper here, I have 2 blue dots, and you're not going to be able to see it. 1, 2 to 1 red. Now let's look at our next example. We have red to yellow dots, and the ratio of red to yellow is going to be 6 to 3. I have 1, 2, 3, 4, 5, 6 to 3. 1, 2, 3. But that could be simplified, because for every 2, I have 1 red dot. 2, 1, 2, 1, 2, and 1. Guess what? So when I simplify that, it would be simplified to 1 to 2. Oh, I'm sorry, because it said red to yellow. So we're looking at red first. So red to yellow. For every red dot, there are 2 yellow. Now, what does simplifying ratios mean? And you have an example, a little box on the bottom there for you to simplify. In the dots example, we changed 6 to 3, 6 blue to 3 red, to 2 to 1, which is 2 blue to 1 red. This is called simplifying a ratio. In order for us to find and simplify the ratio, we find the greatest common factor and divide both numbers by the greatest common factor. And now I have a poster in my classroom that will show us how to find the greatest common factor. So let's go ahead and try to simplify these ratios here. 8 to 2. So we can model 8 to 2. Now, so we have a ratio of 8 to 2. Now, that 8 to 2 can be anything. It could be 8 hamburgers to 2 French fries. It could be 8 students to 2 teachers. It could be 8 boys to 2 girls. It could be any combination of things. But what we could do is we can always create a model, and we have 8. And I'm going to do 8 circles. 1, 2, 3, 4, 5, 6, 7, 8. To 2 squares. 1, 2. So an equivalent ratio could be, and this is how I would create equivalent ratio. 1 is going to go here, 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 and 1 is going to go here. So if we look at it and we just look at this part, an equivalent ratio would be 4 circles to 1 box. So we have 8 to 2, 8 to 2 could be simplified to 4 to 1. Now another way of doing it would be doing it in fraction form, 8 to 2, finding a number that is divisible by both. So this would be divisible by 2, and this would both be divisible by 2. So 8 divided by 2 would be 4, and 2 divided by 2 would be 1. So a simplified ratio here would be 4 to 1. Next one, 18 to 3. Now we can do our model, 18 circles, and I'm going to pause it while I do those circles. Okay, so I drew my 18 circles, and I have my 3 squares. And now what I could do is I could take this circle and put it in here. I'm going to do it in blue. I could take this circle and I can put it in here. Next, I could take this circle and I can put it in our last one. Now I'll go back through the whole process and do this circle and put it in here. I'm going to pull my red. This one and put it in here. This one and put it in here. Now you'd probably find a simpler way of doing it. Now we have the ratio of 18 to 3. That means that there's 18 circles or 18 hamburgers or 18 whatever to 3 of something. Could be 18 pairs of socks to 3 pairs of shoes. We need to simplify it. And in order for us to simplify, we can do it in fraction form, 18 over 3. And we can find the greatest common factor. Now the greatest common factor would be, we would use a T like this, and we would put 18 up here, we'd put 3, and we would list the multiples. So it's 1 times 3 is the only thing that could be on this side. And it's 1 times 18, 2 times 9, 3 times 6, and that's it. Now what is the factor that they have? It's the greatest. Well, this one has a 3, it's the greatest, and it has to be on both sides, so it's 3. So now I would come over here and I would divide the top by 3 and I would divide the bottom by 3, and 18 divided by 3 would equal 6, and 3 divided by 3 would equal 1. So my an equivalent simplified ratio would be 6 to 1. I want you to do numbers 4, 5, the next 3, and be careful, one of them cannot be simplified. I want you to check with somebody at your table, a partner, to see what did they get for this one, what did they get for this one, and what did they get for this one. Now I'm going to go on to another example. After you've checked your answers, you can move on as well. And sharing an amount in a given ratio. So I have a situation here where Bart and Maggie share a bag of 16 candies in the ratio of 3 to 1. So we know that they have 16 candies, and so I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. There's 16 candies. Now, it says in the ratio of 3 to 1. We got to be very careful what that ratio means. 3 to 1. Now, since Bart's name goes first, he would have the 3. And since Maggie's name goes second, she would have the 1. So what does that mean? That means that every 3 candies, this goes to Bart, 1 goes to Maggie, just this one. And then we would go on, these 3 go to Bart. So he has 3 here and he has 3 here. And Maggie would get another 1. And so she has 1 and 1. Bart would get another 3. Since there's still some there to give, Bart would get another 3. Maggie would get another 1. And we have 4 left over. So what do we do with those 4 left over? Well, Bart would get these 3. And Maggie would get that last one that is there. And Maggie would get that last 1. So if we were to simplify it, each of them would get, Bart would get, here's 3. Bart would get 3, 6, 9, 12. So Bart would get 12 to Maggie's 4. So to Maggie's 4. Now I'm going to show you a visible representation of this using a program that we had. And I'm going to go to this situation here. And I hope I got it correct when I was doing it, because I think I might have gotten it backwards. So if we look at this situation here, sharing an amount in a given ratio. Okay, so it says Bart and Maggie share a bag of 16 candies in the ratio of 3 to 1. So here are my 16 candies, just like I did right now. You can use manipulatives to do this. This means for every 3 sweets or candies Bart gets, Maggie gets 1. So now here's what's going to happen. Bart and Maggie can share a bag of 16 candies in the ratio of 3 to 1. So they would get 4. Bart would get 4. Maggie would get 3. Now we're almost done with this lesson, and so what I want you to do is, it says Mr. Morales has a total of 18 Hershey candies. Romina gets 2 Hershey candies, so I start with 18. I have 18. Romina is going to get 2 Hershey candies to Brianna's 1 Hershey candy. So that means that Romina is going to get 2, and so they're going to have the ratio of 2 to 1. Hershey candies. Write the ratio of Romina's candies to Brianna's candies. And so the ratio is going to be 2 to 1. That's our ratio. How many candies will each person get when they divide the 18 candies up into the ratio they will share? So here are 18 candies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And now here is Brianna and here's Romina. So they would have to break it up evenly to figure out who gets what. Now go ahead and take some time to do this. We're almost done with the lesson, and I want to just move on just to one last thing because now it's independent practice. There are pictures for the next couple of them. There's a couple of pictures. There's butterflies, there's soccer balls. Now it says make sure you're looking closely at the images because there is multiple correct answers. So what is the ratio? Which ratio shows the ratio of 2 fish to 3 bears? Now there's an obvious one, and then there's some that are not as obvious. So when you're done with this, I want you to move on and simplify each ratio if possible. So simplify these and create 2 word problems, just 2 simple word problems like I did with Romina and Brianna. And then when you're done with this, you will turn it in to Mr. Morales, and then you will log into Prodigy, and I will have some ratio problems for you on Prodigy.